speed that we can reach for the passenger cars or the bus is up to 100 kilometers per hour. Beyond that, even can we can go on Samruddhi, but what is the safety limit is about 100 or 120 kilometers per hour. By rail, if we go, then the average train speed in India is 150 kilometers per hour. But the China's maglev train, that is magnetic levitation train, and the Shanghai train, even in the France, there are TGV trains. They have taken up to the maximum speed as 603 kilometers per hour. So that is the maximum speed which has been tried by a train. So that is a bullet train that we always talk about. Then for the third mode of transport is air, which has the maximum speed of 956. That has been I have put the maximum speeds which are operative. So this speed is of Boeing 747, which is a common passenger Airbus. So that has a speed of 900 kilometers per hour approximately. And the fourth mode of transport is, of course, boat, that is ship, which has, of course, lower speed than the other three mode of transport. So 62 is for any passenger ship or cruise, that we can say. Fifth mode of transport. So if we think of a transport which should be faster than a plane, or not as faster but as fast as plane, and cheap at the same time. We all know that how much of energy is consumed for the transport, how much of the crude oil we are using for the transport. We know that India is the second largest populous country in the world, and we are the third largest emitter of carbon dioxide gases, or the greenhouse gases. And watching the and not but throughout the world, we can see what are the carbon footprints. And because of this situation of the climate changes, we should now think of a green transport, which should be nearly which should have nearly zero carbon emissions. So there should be a fifth mode of transport. And in 2003, the Elon Musk, who is the founder of Tesla and SpaceX, he sorry, in 2013, he proposed one technology, and he named it as Hyperloop. He published a paper in 2013, and even after 10 years, the still it is under the research and development area. Now, what he suggested was a super speed land transport system. And why it was needed? Because he just took a survey that nearly one uh, person in 40 Americans commute for over 90 minutes to work every day. And even in India, if we see the maximum between the Mumbai and Pune. I searched on the internet and I found that near about 25,000 to 30,000 commuters travel regularly or every day between Mumbai and Pune by train. And there are 6 intercity trains and near about 15 long distance trains which are used by these commuters. And it took near about 25 minutes for this. So Elon Musk just put this idea that we can have a super speed land transportation system which will go by near about 1200 kilometers per hour. So this is much more than the speed of a aeroplane. And he suggested that there should be a complete vacuum in steel tube. So there would be long steel tubes ranging from the source to the destination. For example, we are going from Mumbai to Pune. So there will be a steel tube, and inside the steel tube, there will be some capsule. They call it capsule, or even they call it as pod, POD pod. So these capsules or pods will be containing the cargo if it is a cargo train, and it will be containing the passengers if it is a passenger train. And this pod or a capsule will be floating inside the tube. It will be floating inside the tube. So this floating is nothing but the levitating. The term used by him was levitating. So this pod will be this pod will be levitating inside the vacuum by using electromagnetism, and it will create a very strong enough field to lift it from the rails. So that will be floating inside the tube, and it will be propagated in the linear direction. I will just show you one short video which will just give an idea about the of what hyperloop technology is all about. Even after the video, I'm going to tell you how the technology will be, how this pod is propagated, and how it is lifted over the rails. So we'll just play the video. I'll not play it fully, but I will play it up to just 2 minutes. Is it audible, sir?
No, ma'am.
No.
No.
Uh, so the video's audio is audible or not? That I'm asking.
No, ma'am. Video's audio is not audible.
It's not.
Video is
Okay. Okay. So what I will do? I will do a little bit of commentary over that.
that is fine, ma'am.
Yes. So the main attraction here would be the supersonic speed of the pod. Virgin Hyperloop is the company which has first time tried the this type of technology. This girl that's sitting inside the pod is Sarah. She is the head of passenger experience department, and the man he is Giselle. He is the co-founder of Virgin Hyperloop. And here the levitation theory is being explained that there should be such type of seats inside the pods to seat for the passenger, and this aeroshell is designed in such a way to have the minimum air drag. And the material used for the pods carbon fiber because it is lightweight, and this is the chassis of the pod. It is also made up of carbon fiber, and below this pod there will be a levitating chassis which is in which the electromagnets are used. So how that magnets are used, that I will in the next slides. Now, the key feature of this hyperloop is the levitation. That once it gains sufficient speed, the wheels will go inside the pod. That means they will be just winded up, and this pod will float without any friction inside the tube. And there are the guideways. Even the guideways are of electromagnets. That means there will be actuators to induce the magnetism in the material, in which some magnets are placed in a different way. That means it is called as Hallback array, and all the directions of the magnets are a little bit changed such that it will create a strong field which will repel the pod up of the track. In the next slide, I have a diagram from which I will tell you how that pod will be lifted up and how it will be floating in the. It is just a repulsive magnetic force. It is a repulsive magnetic force which is repulsing the pod. Okay, so what I will do, I will stop the here and go on the next slide because anyway the video, audio is not there. Yes. So yes, we have already talked about why do we need Hyperloop as a better transport system, or we can say that this is the future train of the world. So just to reduce the congestion between very commonly commuted cities like Mumbai, Ahmedabad, Mumbai, Pune. See what happens for these particular cities where there is a lot of trade happening between the cities. If someone wants to go from Nagpur to Raipur or from Nagpur to Pune by flight, it takes nearly 10 minutes to fly. Even when that air hostess gives you a chocolate, before it is melted in your mouth, you reach up to your destination. But the time which is taken up for the check-in time, the luggage picking up time, and the security check, all this takes near about 50 to 60 minutes overall. And the traveling time, again, near about, it takes a lot of time when you go by flight, between the shorter distances. I'm talking about the shorter distances cities. So we always want a convenient mode to connect the metropolitan cities or the cities with trade, like I'm talking about Mumbai and Ahmedabad, Chandigarh and Ludhiana, and this way. And again, at the same time, we want a cheaper alternative than flight, because aeroplane is not everybody's cup of tea every time. Again, the time at which you book the tickets, that will be varying. So that is, we always want a cheaper alternative and a less polluting than air travel. So the Hyperloop is a technology which will be completely clean. If it is even we can put the solar panels laid on the tube, so that that becomes a completely clean energy system. Now let us see about the technology. Now the technology in the used in this train would be purely magnetic levitation. So as I have told you in the video, as we have seen in the video, that the pod, which one that blue color pod, that will be levitating inside the steel tube. The material of the tube would be steel, and levitation is nothing but the ability of a material to stay suspended above the track. Now here the train, this train will be using three sets of magnets, in which the first set would be to repel and push the train up of the track, so that the pod will be lifted up and it will be stay suspended above the track. So that is the function of the electromagnets set 1. There will be set 2 of electromagnet which will move the elevated train ahead. So there will be linear motion of the train. So that will be taken care by the another set of electromagnets. And it is again our duty to put the pod in the center of the tube. It should not go on the right or left side, and it will not just go about off center of the track. So for that, the third set of electromagnet is put inside the steel tube. So for understanding the magnetic levitation, we have a very small experiment that is done. So there will be a set of magnets here put. This is a very small experiment, just to understand how that magnetic levitation, or in short, we call it as maglev, it is done. So see, there will be a repulsive force of magnetism, which will push the pencil off the red plate, because the arrangement of the magnets is done in such a way that it will repel the pencil up. Let us imagine that this pencil is a pod, and inside the pod the passengers are seated. Even the batteries are on the board, that means in the pod the batteries and the passenger both are there, and the electromagnets which are laid down the guideways, they are pushing up the pods upward. So that is the experimentation for the set 1 electromagnets that will push the train up. Now how it can be done? So for the levitation, that means for the keeping the train or the pod up the guideways, there are two methods. There are two methods to levitate or to suspend the pod in the tube. The first method is called as EMS, that is electromagnetic suspension. This electromagnetic suspension will use the attractive force of electromagnets placed on the guideways and on the train to levitate. So one electromagnet will be on the guideways and one electromagnet that is of the opposite side of force, it will be kept on the train. Now this is much simpler technology. and at high speed it is difficult to maintain the correct distance between the train and the guideways. Now one question must be there in event that how much pod should be lifted, because it will be heavy. Near about right now, the various technologies that are being researched for this is up to 16 tons. That is the maximum weight that is being considered is 15 ton. So this 15 ton that should be floating in the tube. So how to put the correct distance between the guideways and that distance is only 15 mm. So you can just imagine the tolerances, how crazy those tolerances would be, and how difficult the design and would be in that case. So we must have a complex feedback control system even for this EMS system. Then another idea of levitating is electrodynamic suspension, that is EDS, which uses a repulsive force of electromagnets. This is the most commonly used technology for levitating the pod. They will use the repulsive force of electromagnetism, but there is one small limitation to that this repulsive force will only work when a sufficient speed has been maintained for the pod. So initially what is done, there are certain auxiliary wheels connected to the pods. So initially the train will run on the auxiliary wheels, but once the sufficient speed has been built up, then these wheels will not be there, they will be taken upwards, and the pod will get levitating, it will get floating very freely inside the pod. What Elon Musk has suggested that there should be complete vacuum in between the tube and the pod. So there will be absence of air, because what happens in all the four modes of transportation that we have already discussed about, the main challenge to go about is the air drag or the air resistance. Because whenever we are propelling in certain direction, the first and the foremost thing is to displace the air in which is there. So if there is not at all air in the tube, then there should not be work done to displace the air. So there should not be air drag. There should not be air resistance. So the efficiency that we will get here is the maximum, and that is the reason why we can achieve this amount of speed. When we talk about nearly 1200 kilometers per hour, this is much more than the aeroplane speed, that is 700 or 800 kilometers per hour. And this is possible only when we will maintain the complete vacuum. But as the research went ahead, and all the researchers around the globe, they understood that it is impossible to create complete vacuum. I mean, impossible means whenever there will passengers coming down of the pod, they will again in the next station they will be there, next passengers will be there. Every time maintaining the complete vacuum inside the cavity, that is always difficult. So the idea what many researchers came with was that we should maintain low pressure inside the tube. So there will not be complete vacuum, but there will be low pressure which will be maintained, and so there will be very less air resistance to resist. So the most commonly used technology to levitate the train is electrodynamic suspension. Now, next task is, once the train is suspended, next task is that the train should go ahead. It should move in the forward direction. So how the linear motion should be given to the train? So the answer to this question is the linear induction motor. So motors are used for giving the speed. So how this propulsion is done? The propulsion basically that is the force that will drive the train forward. And these magnetic levitating trains, that is maglev train in short I will call it. The maglev trains uses electric motor also. And we know what is electric motor. The normal electric vehicle, it uses magnetism to create the torque and spin the axle. But in the normal electric motor, it uses sorry, it has a strong stationary piece in between. I can show you this A, capital A, that is the rotor, and surrounding it to it there is a stator. So we call the rotor as secondary and we call the stator as primary. This stator is used to generate the rotating magnetic field, and this field induces a rotational force on the rotor which causes it to spin. A linear motor is just an unrolled version of this. So what motor we are going to use in the hyperloop is just if we unroll the outer winding, that I'm calling it as stator. If we unbound it and if we put it in a linear direction, then such type of arrangement, that is the third diagram I am showing, such type of arrangement is called as linear motor. So this motor will give a linear force. It will experience a linear force. So how it is done? The stator, that is B, part B, it is laid flat, and it is laid flat on the guideways. So in the complete tubes, right from Mumbai to Pune or from Los Angeles to San Francisco, whatever is your route, so from one destination to another destination, the stator is laid flat and the rotor rests above it. Now, instead of rotating magnetic field, see in the first diagram there will be rotating magnetic field, but in the third diagram there will be linear magnetic field, and that is why we experience a linear force, and that is why we can give a linear motion, linear forward motion to the train. And such a motor is called as linear induction motor. But there is a small drawback of this induction motor. This drawback is that the secondary, that means the rotor, it always lags behind. There is always a lag. That is because of maybe the AD or some losses. It always lags behind. And that is when the linear synchronous motor comes into the picture. So instead of this LIM, that is linear induction motor, linear synchronous motor, that is LSM, is used in the hyperloop technology. So what is done in the synchronous motor, that a permanent magnet is used, so that the secondary should not lag behind, and we should get a unstoppable linear force for the train. So I will just repeat once again that for the levitation, see there are two types of motions. One is levitation, that means lifting up the pod beyond the guideways. So that is done by the electrodynamic suspension technology, in which repulsive force of electromagnets are used. The second motion that we want is that we have to move that pod in the forward direction from Mumbai to Pune. So in that case, we are going to use a linear synchronous motor, which will push the pod in the forward direction. And what is done in the train, that secondary is always attached to the bottom of the train cars, and the primary is nothing but the guideways. Guideways means the bottom of the steel tubes in which pods are floating. Sir, if in case there is some voice problem or something, please let me know.
No
Now
problem.
the third challenge is to keep the pod in the center. So that is why a third set of electromagnet is used, so that this pod remains in the center of that steel tube. I will just show you one diagram. See in the first diagram, our standard railway system is shown, in which there are railway tracks, and the train is moving on the railway track. The second one is a trans rapid guideway. The name given to this is trans rapid guideways. Actually, this name was given by France company TGV. They had one research over this technology, and they given the name to this train as trans rapid train. In every country, the research on the hyperloop technology is going on, and this research is going on since long, and so that is why everyone gave its own name, its own terminologies to this technology, and this terminology comes from France. So this is a trans rapid guideways, in which we can see that there are electromagnets to keep the pods floating, and in the sideways also there are electromagnets to put it on the what I can say in the center. And the third one, design is slightly changed. sideways. That is a design given by the Japan. So there are three sets of electromagnets. We can show it from, I have shown it from blue arrow, red arrow, and green one. So the blue will just lift up, green will put it in the center, and red one will take the pods in the forward direction. So I have named this as levitation, propulsion, and guidance. So LPG technology. You will not see this term anywhere in the internet. I just thought that we should give some name to this technology. So I have just taken the short form of each of the motions, LPG. Yes. Now let us talk about the pressure in the steel tube. So this black line below, that is the reference line, or we can call it as datum line. That is the sea level pressure that we always call as 1 bar. The normal atmospheric pressure is always 1 bar, and that is equal to 1.01325 into 10 raised to power 5 Newton per meter square, or in short here it is given in pascals. So 101325 Pascal, that is the normal atmospheric pressure. Now, as we go up, the pressure reduces. As we go up, the pressure reduces. The second dot, it is for Mount Everest. So Mount Everest, which is near about 1,000 feet, the pressure is always 35,000 on the Mount Everest. After that, the commercial airline, which is there in the air near about 30,000 feet, the pressure is 20,000 Pascal. This is the Armstrong limit of 60,000 feet. This name is not given on Neil Armstrong, but this name is given by a physicist Armstrong, who has discovered a phenomena that at 60,000 feet and at this 600 Pascal pressure, the normal temperature, the normal body temperature is itself the boiling point of water. So if we go at 60,000 feet and if we experience this 6,300 Pascal pressure, our blood will start boiling. This is the fourth dot. The first one is normal air pressure. Then this is for a Mount Everest. Above that comes the commercial airline. Above that goes the Armstrong limit. So even if we go at 60,000 feet, our blood will start boiling, and within few microseconds, we will be no more. So that is what low pressure is there. After that, if we again go up of the atmosphere, there is a stratos jump. It, if from the stratosphere, if anyone jumps, then the pressure experience that no one will be there. Even at 60,000 feet, the person will be no more. So even if at by all the technologies, if you go at this certain limit at 400 Pascal, that is called a stratos jump. And now comes the red dot, where we'll say that that is the pressure inside the hyperloop tube. But don't be afraid, that will be the pressure between the pod and the steel tube. Inside the pod, there will be normal atmospheric pressure in which the passengers are sitting. So for a passenger, there will be no such inconvenience as temperature and pressure taken care of. So there will be normal pressure and normal temperature put in. Now this is the design given by the Elon Musk in 2013, and the thing started from this design, that he told that there should should be the design of a pod. There should be seats, so near about 28 people he thought of that we should carry in one pod. And see, this hyperloop will be having only one pod floating above it. The next pod, which will be separated, so there will be no connection like the train bogies. Like train bogies are connected with each other, there will be no such connection between two different pods. But the one pod will be separated by another pod, and the distance would be 37 kilometers near about. That is the breaking point, because if the train above, that is the pod which is ahead, if it stops in case or there is sudden power failure, then the behind pod should be job by itself. So people are trying to make all these things autonomous, that if the first pod let's say it stops suddenly, the second should stop. So this all should be autonomous. This inlet fan and compressor, this design is no longer in use right now. No company right now is working on this. This was a very initial design given by the Elon Musk, that there should be a compressor which will compress the air, and there will be an air cushion in between, because see, we have to displace the air. So that was very rough design given by him, but as we should know the history of the design, I have put this on my slide. But other design like this aerodynamic shape, that is kept as it is, and the batteries are carried by each of the pod on board. So each of the pod will be carrying the batteries for the electromagnetic actuators and everything. Now, who are making this hyperloop trains all over the world? So there are so many companies here, near about 10 companies, but the Virgin Hyperloop one has the latest technology, and the great research is going on in this company. Even Maharashtra government had done one MOU with Virgin Hyperloop one to make a Hyperloop train between Pune and Mumbai, but after that the government changed and that MOU was cancelled. But now we can again hope that that project will again come into the picture. So these are the makers all over the world. Now let's see what is the timeline, that how this all transport system of the trains came about, and how we have reached up to the hyperloop technology, how that concept was conceived, everything. In 1830, the first locomotive ran at 50 kilometer per hour speed. So see, from 50 kilometers per hour, now we are hoping for 1000 kilometers per hour. So as in the initial slide, I said that we are craving for hyperloop. So that is this, that we are after the first locomotive train in 1903, we got the first electric rail car, which was then at 210 kilometers per hour it ran. Then in 1964, actually, what technology that we are seeing right now, that started in Japan in 1964. That the Shinkansen, that was the name which is given in Japan, but the world recognizes this train by the name bullet train. So the first bullet train started in Japan in 1964. I mean, no one of us was, I think, would be there at that time. So first high-speed train, that was bullet train, was in Japan in 1964. After that, in France, there was a company. There is a company called TGV. That is into the rail fabrication and design business. So they just took the idea of bullet train from Japan, and they built their own first train, which ran with a speed of 260 kilometers per hour. And I think the first ever in the Europe. Then again, from 260 kilometers, they reached up to 300 kilometer, and it took near about 8 years for the France to reach up speed 300 kilometers per hour. And in Japan, like 1964 was the starting point, but in 2003, the first magnetic levitation train was operational in Japan, which ran by with a speed of 500 kilometers per hour. 500 kilometers per hour. So this is exactly the starting of magnetic levitation theory, because this train levitated with electromagnets, but the propulsion was done, of course, by the electric lines which were supported there, overhead electric lines. So the speed was 500 kilometers per hour. Now, what difference the Elon Musk design has, that this maglev train which ran in Japan, that was in the air. I mean, it was in the open air, so it has to cater for the air resistance that it was experiencing. But the hyperloop, because there is no pressure or absolute low pressure inside the tube, there will not be any air resistance for that. So that is the big difference, that the bullet train or the magnetic levitation train running all over the Japan and the hyperloop technology that Elon Musk is proposing, that has. Now, after that, in the competition with the Japan, who ran with 500 kilometers per hour, France made a world record of 574.8 kilometers per hour, and that is still there. This record is still there. So in 2007, the France made this record. Then in 2013, I have not put in the slide, that research paper by Elon Musk came, and after that many researchers were into the research, many R&D companies were into that, and high speed rails around the world were laid, and the total track of these bullet trains all over the world was 30,000 kilometers. And after 2015, and now we are hoping after 10 years later, that is after a decade, that the hyperloop should run by 2025, with very high speed of 1000 kilometer per hour, even beyond the flight. So this is how the timeline will go about. These are the approximate locations of the proposed routes. That is in Mumbai, one route is showing, that is from Mumbai to Pune. In Punjab, the Punjab government in 2019 made one MOU with Virgin Hyperloop One, and they told them to make one Hyperloop for them from Ludhiana to Amritsar. Sorry, from Amritsar to Ludhiana to Chandigarh corridor. Then right now in California, that is the green, this marking is there. This company is Virgin Hyperloop One, that I have already told, that that is the most recent technology they are using, but they are going with the Elon Musk's idea. But the Hyperloop One, that is the red mark and the gray mark and other proposed routes, they are using some other technologies. They have slightly made differences with the Elon Musk's idea, according to the convenience, according to the economy, everything. Later on in my later slides, I am going to talk about the economy of this train as well. Yes. Now, what is the, let us talk about what is the current status of Hyperloop. I mean, here we have already seen that in Punjab and in Mumbai, there are plans. Government is planning to do the Hyperloop, but what is the exact status of Hyperloop technology in India? So our ministry, that is central government, of course, Ministry of Railways has done one MOU with IIT Madras, that they will build a Hyperloop system under the Make in India initiative. So this Hyperloop technology, this Hyperloop train will be completely indigenous to India and will be completely made in India project. So it will also help this Minister of Railways will also help the IIT Madras build a center of excellence for Hyperloop technologies, and there will be research and development going on for this particular project. Made in India and IIT Madras, they have talked to railways about the Hyperloop in March 2022. So since then, this project is going on, and near about 50 students of IIT Madras who are passed out in 2017, they are still working for this project to make the Hyperloop technology in India. Even like I said, that Punjab government has also done different MOU with the Virgin Hyperloop for making the Hyperloop for their state. Now, yes, this is the most important question till now, that can our bodies handle the Hyperloop? Because we have handled the acceleration that is there in the flight, but can we sit in a pod which is just hovering inside a steel tube which is having no pressure or low pressure, and that will be accelerating? Because uh, I mean, consider the speed is simple, but the acceleration, when it comes to the derivative of speed, it is always difficult to handle. See, the gravitational acceleration that we are always experiencing, that is 9.81, that we always denote by small g, that is 9.81 meter per second. But the hyperpods, they are accelerating accelerated by more than gravitational acceleration, near about 0.1 to 0.3 times the gravitational acceleration. And many researchers have asked this question, and they have on the internet also they have put some their research published in different journals, that there may occur nausea if somebody has just taken his lunch and sit inside the pot. He has to say bye bye to his lunch anytime. So that are the researchers globe wise they are telling. But the companies that are into the making of this hyperloop, they are telling that they are always they are always thinking of the maximum acceleration that body can handle. See, some of us can may have gone to the Disney Wonderland and the various adventure rides that are there. So, as a fun, we can handle them. I mean, for body, it is very easy to handle such type of or this level of acceleration. Whenever there is air drag, there is air suspension. But what the companies are telling, that inside the pod there is no such thing, because inside the pod the pressure will be extremely simple. I mean, it will be normal pressure and temperature condition like that. So the makers are saying that there will not be any difficulty in handling this speed to any human being. And again, a big challenge that one can face here is the economy. Elon Musk, when initially he evaluated this project, he said that the cost of one-way trip to from Los Angeles to San Francisco would be $20 per passenger. So, with today's conversion factor of rupees and dollar, it nearly comes about 1600 rupees. 1600 rupees. So I hope that with the speed that we are going, this is very comfortable idea of having 16,000 I mean price of a ticket. But when actually, because this idea was kept forward 10 years back, and lot of things have changed. GDP has changed all over the world. The inflation has increased. So the makers around the globe, they are saying that whatever economy Elon Musk had put forward, now just multiply by 3 times. So everything is now very expensive here. But if they increase the capacity, if they increase the capacity of the pods, this will obviously come down, and that is why there is a lot of time to come this into the picture, that right now Virgin Hyperloop, even Hyperloop TT, all over the globe, they are trying to just calculate the mass, the amount of mass that they can levitate at the same time with the electromagnets available. Because the battery weight they have to always look for, they cannot exceed the maximum limit of the I mean weight. So with the available battery that they can carry, what amount of mass we can put, or if we can add some cargo to it, and they are just seeing that economy. See, when hundreds years back, when the Indian Railway was laying down so much of steel as a track, everyone was amazed that see how much of amount of steel they are just misusing. But see the amount of usage the Indian Railways has done to it, and just take an example of the payback period, that with this amount of price of a ticket, how much should be the payback. So if you take or if you consider the advantages of this, the makers are saying that this is always economical. And if you look for the carbon emission criteria, then as we are using clean energy, as we are using the solar panels above the pods or above the tubes, this is always economical. Now all the figures that I have put is in dollars, because right now the makers are in US or in Japan or in France. So I just converted this 4.8 billion US dollars in rupees, and I just could not read the figure. So initially we feel that this is a huge amount. but the usage over the 20 years, or even we can thought of more years, that will be paid back to us. Yes, and now let us discuss what are the challenges ahead for making the Hyperloop. Because why it took 10 years and still maybe 2 to 3 years more to Hyperloop happen into the reality. Why we are not right now traveling in Hyperloop? The reason is these much challenges. The first one is very that is many researchers have put this idea forward that we cannot handle the acceleration, but this has been ticked out that people have already done the research on this, that yes, we can handle the acceleration in flight also, we can handle the acceleration, even in the pods we would be able to handle the acceleration. So they are saying that they will not exceed the acceleration than 0.3 times the gravitational acceleration. The second challenge is, of course, economy, because the sponsors are not that ready to sponsor this very high aimed project. Then what if sudden power failure happens? So this is the system where people have to work on, because there should be auxiliary wheels. So in case of power failure, they should come up. So that is one problem. Not, we will not say problem, but that is a challenge for the researchers. Then see, everyone who is working with the Hyperloop company is the researcher right now, because nothing has been there in the reality and they are just trying and testing different sort of technologies. The fourth most important challenge is the battery mass calculation, and to maintain that power to mass ratio, that is an extreme challenge for the companies. So to provide a high power to mass ratio required for making the Hyperloop efficient. Now see, when battery mass required to power Hyperloop is too high, and if you compare the amount of cargo that is traveling, or amount of people, that only 28. So if you see, the mass is very less, but for that they have to carry lot of, or big batteries. See, any electric car that will be having 75 kilowatt battery near about, but this pod will be carrying 200 kilowatt of battery. So that is a huge specification for any battery, so it will be very heavy. Then the next challenge ahead is we have to have a cheap and automated infrastructure, because whenever we have to construct the steel tubes, whenever low pressures are maintained in the tube, you can just see that how accurate tolerances it will have. And to create these tubes, to manufacture the pods, to have the low pressure maintained, to have the electromagnetic actuators and everything, we need we will be in the need of special processes, special manufacturing processes to make all these things, which again increases the cost of assembly. Because when we talk about economy, there is capital cost, then there is operational cost. So operational cost comes with the maintenance, the salaries of the staff, the maintenance of the stations, like the metro stations nowadays. We have in Nagpur, there is Maha Metro. So you can see how in big infrastructure is created there. So this infrastructural cost as well as the operational cost, these are the big challenges. And in operational cost, always the cost of assembly is included, and cost of assembly has the cost of manufacturing processes that we need to create for that. Again, one more challenge is that Hyperloop needs more advanced cooling technology, because when a pod is hovering with a speed of 1000 or 1200 kilometers per hour, see the amount of heat which may be generated there with that speed. Though there is no friction over there, but still with the electromagnetic magnetism and the batteries, there would be requirement of advanced cooling technology. So air cooling is not the answer, because we are not putting any amount of air inside the tube. Why we are not putting the air inside the tube? Because if we calculate, then inside the steel tube, 70% of the tube's volume is taken up by the pods. So we need pod will move forward, so the displaced air, where it will go, because there is no such area that for that to go out, because there is a steel tube. So that is a big challenge, that to displace the air, where this displaced air will go. And the answer to this is the low pressure, that you should not put the air inside the tube. But if air is not there, then we cannot use the air cooling there. So we should be using again either oil cooling or some other refrigeration system. But see, the refrigeration system again will have its own components. It will come with a compressor, condenser, evaporator, and expansion valve. These are the four basic components of a refrigerator that we know. And again, there will be mass associated with it. So to maintain the power to mass ratio, again, it will be difficult if you bring along the refrigeration system with it. So cooling technology is a big challenge. Now, why I am giving more time to this challenges slide is that being academicians, see, all of us, I guess, are either academicians, teachers, faculty members, researchers, or students. So what role we will play in this hyperloop technology? Because see, the title of the STTP is on emerging trends in mechanical engineering. But as we know the emerging trends, we know the common problems. When we come along with whenever we come along with the emerging trend, there are common problems that are there, challenges that are there to answer. And these are the questions that researchers, faculty members, even academicians like us can answer. So we can work on small project. We can just have a small prototype of slide I shown you, in which pencil was levitating with the electromagnets with the use of repulsive forces. So we can just carry out small projects and answer to the questions that researchers all over the world are now dealing with. Like IIT Madras students are putting their all efforts to make the hyperloop into reality. So the cooling technology is one more challenge that we have there. Now let's make this long story short. I'm just winding up my lecture in some time, because actually the time given by BCSR was 1.5 hours. But at 2 I have to go somewhere. We have NAC visit tomorrow, and the delegates are coming one day before. So we have to do certain preparations there. Of course, you can surely understand. So I'm just making this long story short, and I'll tell you that what the thing is all about is to accelerate a certain amount of mass at certain acceleration. Now, the total force required to move the system would obviously mass multiplied by acceleration. But in this case, we have to reduce the drag. I mean, there would be some air drag if some air is there, and the electromagnetic drag. Why this electromagnetic drag comes there? Because whenever we use electromagnets, AD currents will be formed, and these AD currents are the losses that we have. So this mass multiplied by acceleration, sorry, I should have put a bracket here, mass multiplied by acceleration, bracket complete. And then we have to just subtract the air resistance and the electromagnetic losses that are there. So therefore, first of all, the open problem or the area for our work would be to optimize the mass. And this mass becomes very heavy because of the battery. The second one is to reduce the air drag. So we can build cheap pressure management system for long tubes. And again, there is another limitation, that the tubes are very long. Like whatever is your track, that much long tubes will be there. So that is another limitation that we have in the system. The third one is to design efficient electromagnetic actuators to reduce the electromagnetic drag. So we should design the electromagnets in such a way that there should not be the EMF generator, that there should not be AD currents generated there. So electromagnetic drag is minimal as compared to train and track friction drag that we have in the normal train I'm talking about. that will always be less than that, but that is there, so we can work on this. So these three are the scopes that I could recognize where we can work on. We can have our share our viewpoint on that. That is what I got from this hyperloop technology overall. Some Indians working in US on Hyperloop technology. These three people are working in. I just put this slide that what is the role of India in making this project into reality. So our role is that we have sent near about 25 Indians there to work on the Hyperloop technology, and these three are from Maharashtra. Kunal and Tana is from Pune. Kunal is taking care of the load design department. He is the head of load design at Virgin Hyperloop One. Ketki is head of power electronic unit at Virgin Hyperloop One. And Tanay, I would proudly say that Tanay is the first Indian to ride on a Virgin Hyperloop. So he has tested the Hyperloop there. So though they have made the testings and all that, but they haven't commercialized it because it is not yet open for the passengers. So these are my references, and thank you. So if you have any questions, I'm open for your questions. Excuse me, sir. He says, sir, you
Yes,
can
ma'am.
put the forum open for questions.
Yes, yes. Already done, ma'am.
Yes. Okay, sir. If any, okay, in chat box. Okay, thank you, sir.
Okay.
Yeah, I will put my number in the chat box or an email ID. So if anyone has some questions, I'm open for solving.
Okay, fine, ma'am. Also, share, ma'am, PPT so that.
Okay, sir. I will share my PPT.
Okay, thank you.
Thank you, sir. Thank you very much.
Okay.
Shall I leave the meeting?
Yes, ma'am. You can leave, and all the best
Thank you
for
so much,
your
sir, for giving
committee.
this opportunity. Yes, thank you, sir.
So all participants must uh, fill the feedback form, which link will be available in 10 minutes on our WhatsApp group. And faculty can leave. So thank you.